Okay, this is the Lollipop Redox reaction. This is actually the last demo that I'm gonna do. And I saved it for last because I've never done it before and I'm really excited. So for this one this is a teacher demo because you need sodium hydroxide and you need potassium permanganate, which are not things you can easily get or store. You need distilled water. So again, I've just poured that so it's a little bit easier to pour, ready to go. And I have a graduated cylinder to measure out the amount. I have a stirring rod, you could use a spoon. And then the biggest part, because you need quite a bit of thorough mixing, is I've used a milk frother. And luckily mine comes with 2 heads, so I can use one for chemistry experiments and one for lattes, and I don't want to mix those 2 up. What I've done is I've just taped a lollipop to the end of it. I guess I should open it up actually. And it's just going to allow the mixing to happen faster. It's not really, my mixer isn't, the frother isn't that happy to have something attached to it, but it should work. And you just won't be able to mix it fast enough with your hands and worry about spilling. So this is actually able to go fully in here and mix and keep it contained, versus if you had to swirl it to mix it, it just wouldn't happen as fast. And because we don't have an electric stirrer here at my house, this is what we're doing, and this is actually what the experiment says to do. So let's get started. So I've taken the wrapper off. It doesn't really matter what color you use. It shouldn't really impact the color changes that we're going to see. So this is going to be a redox reaction, so an oxidation reduction reaction, and it's going to involve the sugar that's in the lollipop and the manganese in potassium permanganate. So this is actually going to change oxidation states or oxidation numbers. Permanganate has an oxidation number of +7, and we're going to bring it down all the way to +4, and each color change from 7 to 6 to 5 to 4, and then just an extra of sugar as well, will allow you to see sort of a range of 5 different colors. So the glucose is being oxidized and the manganese is being reduced, and that's just facilitated by the basic conditions. And so you can apply this to a lot of biochemistry and a lot of organic chemistry, which he'll talk about both in grade 12 chemistry in the organic unit and grade 12 biochemistry in biology if you take that. So this is just a fun visual example of a visual version of a redox reaction. So the first thing that we're going to do is we're going to measure 200 ml of distilled water. And we're going to pour that into the Erlenmeyer flask. You could use a beaker or like a big measuring cup as well. But the reason Erlenmeyer flasks work best is because of this pinch top. It allows a lot less spilling to occur and splashing. So that's our 200 ml. And I'm just gonna add a tiny little bit of sodium hydroxide. It calls for a few pellets. I actually have granules, so it's a little bit different. So I'm hoping that it will be enough. Or equivalent. We will find out. If not, I'll have to start it again. So I'm just gonna swirl it a little bit to see if I can dissolve it. If not, I have a stirring rod. You want it completely dissolved. I actually have a stirring rod. It will generate a little bit of heat. There isn't that much right now. And that should be good. The next part I'm going to add is just a tiny little bit of potassium permanganate. You just want a little, because if not, the color will be too dark and you won't really be able to see what's happening. Even that, I'm hoping, isn't too much. Hopefully that's okay. So that's the color of manganese's regular +7 oxidation state. And let's see if we can get it to go through all of them. Now, some of them will happen pretty fast. So we're going to expect our color change to go from purple to blue to green to yellow to orange. So let's see, you can have sort of like your phone ready to see if you can get all of the pictures, because obviously I won't be able to get them. I'm filming on my phone right now. So let's hope we can get all the colors. Let's see what happens. So all I'm doing is pushing this in and I'm turning it on. Try not to hold it too high. Oh, it's going darker purple. We have blue and green. This is really cool. These ones happen fast, and then the next ones take a little bit of time, but it is lightning. The green, and it's supposed to go a yellowish color, which it is. I feel like I'm holding a shake weight. Oh, it's going later. That is really cool. Now it's yellow, and that is turning more of an orange color. And it doesn't matter what kind of lollipop you use. Like, it's not the lollipop that's changing the color, like the flavor of it. That is so cool. And if you don't believe me, I can do it again with a different color lollipop and you'll get the same results. That is really cool. So that was all of the +7, +6, +5, +4, +3 as the glucose was donating more and more electrons as it dissolved to the manganese. And that's pretty much it. So fun.